You might not know us because our work is behind the scenes. See, what we build and the solutions we provide, while teamed up with companies and engineers in all kinds of industries, has everything to do with making your day better. Well, actually functional. See, Phoenix Contact is more than just a manufacturing company. Our solutions and technology help simplify, connect, and improve everyday life, making all our lives easier, faster, safer, brighter, and richer. Because you deserve a quality life, and we're excited to make that difference. Not just in what we build, but in how we support the people who use it. And it's exciting to work with inspirational partners who share our vision to achieve goals that support sustainability. And we're building technology that drives energy efficiency forward because we know it can improve lives. We've been at this for more than 100 years and believe the best is yet to come. So join us as we keep pushing forward to empower a smart and sustainable world for future generations.
Hi, I'm Dave Eifert from Phoenix Contact, and this is Josh, who will be joining me today. Today we're going to talk about what we've brought to the show here, ProveIt 2026, and our basic thing that we're trying to solve is all around data. So everybody at the show knows the importance of data. Small to medium-sized manufacturers are starting to wake up to the fact that data is the new oil. If you look at the largest companies in the world, things like Google, Alphabet, Meta, all these companies are founded on the value of data. They wouldn't exist if data wasn't there, and they're worth trillions of dollars. That applies also to people in all kinds of manufacturing fields, not just these big data companies. So it all starts with the data, and there's plenty of vendors around here that are all software related that really do things that are pretty cool with the data once they have it. But we're the ones who are right down at the ground level to actually get the data out of the factory in the first place. It's been called the new oil in terms of it's a raw material, it's very valuable. And you could think of the software providers around here as maybe a refinery, somebody that's improving that data, turning it into information and something really valuable. But we are the raw material. We're helping to produce the raw material, that is the oil or the actual data in the first place. So we'll show how we've got a PLC called PLC Next that functions as both a PLC as well as an edge gateway to attach to the sensors into the field, to perhaps attach to another PLC in a brownfield situation. And we will take any type of thing that we're connected to and then make it available upstream in open protocols and per standards such as SESME or OPC UA, etc. So we'll have Josh here actually running some of the computer behind me to show off these different things, but let me just kind of finalize this overarching point by saying that, you know, if you can't measure it, you can't manage it, and without data, there's nothing to measure. Without good quality data, good fidelity data, contextualized data, it's not really very useful. So we are kind of the bedrock part of the entire equation to start the whole process, to give you a good outcome, to give you good data that can go into AI and ML or go into any type of application you might have. So with that, we'll talk about our two demos here, both based on PLC Next. On the left, we have a game that we're here showing in our booth that's just kind of a fun, frivolous thing, but it's also kind of generating data that can be an analog to what's going on in a factory situation. At the same time, we are sending it up to a SCADA system, which happens to be Inductive Automation's ignition system. And we're going to be using OPC UA as well as MQTT protocol to do those things. So Josh, if you wanted to either jump on there or onto the computer, whichever you think's better, that would be great. Thank you.
So on our screen over here, what we're seeing is our IDE that is used to program our PLCs in a more traditional sense. And so what we have going on here is we have both the OPC enabled, picking which structures, UDTs that we want to be available for our ignition or our visualization environment. But in addition to that, we are also publishing that data into the broker here at the show that UNS that everybody's using. And so if I come over to, in this case, our program, we have a MQTT library that we're able to bring into our IEC 61131 environment, connect to the broker right from the PLC, and publish into that space by using these function blocks that are available to us, specifying the topic, choosing the value that we want to be available. We can do this in a single element, or we can also do this in JSON. And so in this case, what we've done is adhere to one of the standards provided by SESME for this demo and made that available on the UNS. And so to drive the point home here, we are programming this PLC in a traditional sense, but at the same time, it's available outside the edge. And so on one device, we are able to do traditional PLC logic things that we've shown here in a gamified way or as an I/O exerciser, but have also made this an edge device so that these other applications here at the show can use our information. And so I'm going to switch now over to the broker, where you can see under Enterprise B, we have our topic Phoenix Contact, in this case our memory game, and some data to go along with that. And then if we go down to Enterprise C, we'll also see that we have a similar structure here for our I/O exerciser. So I'm going to kick it back to you, Dave.
Excellent. Thank you, Josh.
Yep.
So Josh got down to the nuts and bolts of it to show that we're actually doing what we're saying we're doing. It's kind of the ground level necessities to get that data from the sensors, from maybe a existing brownfield PLC, or from any other place way down in the plant floor where it's actually happening. So we take it through these open protocols and through standardized interfaces, make it available through the unified namespace where it can then be shared all throughout the organization to different applications where they can be enriched or actually interface with a human being to make some kind of action happen. So in this case, we've shown the inductive automation system, we've shown the broker, and it could have gone to any number of other analytical software packages or start to feed an AI or ML workflow, in which we've also been able to execute right on the edge, right in the PLC itself, or in the cloud, doesn't matter. So I guess in summary, what I'd like to really point out here is that as companies embark on their digitalization journey, which they realize is a necessity just basically to survive as a company, the thing that's been holding people back is just paralysis by analysis. They see all these different ways of possibly doing things, and they don't know where to get started. So we would like to offer that if you were to start with something like PLC Next at the ground level, it's open, interoperable, future-proof, it's inexpensive, so you're not going to be vendor locked if you go this direction. Very open. As an example, with the PLC Next device that we have behind us, yes, Josh was showing our own software, PLC Next Engineer, being used to program it in a traditional PLC kind of way, but that's only one option. If somebody is more familiar with a higher level language, they could have used the Linux aspect of the PLC to program in a programming language they're more comfortable with and still get to the same net result. Conversely, or I guess additionally, we could even load a competitor's IDE or competitor's control software like Codesys right on our device and let them operate if that's the interface you're comfortable with. So you're not going to get locked in by choosing this hardware. It's a great platform, it's inexpensive. It'll get the data up into the unified namespace where then it can be shared with any number of different applications with no fear of being locked into a certain path. that you can't escape from. So I think we're supposed to mention the problem that we encountered or are trying to solve, and then the cost for the solution. And the problem, as we really say, is what I just reviewed, is that everybody needs to digitalize their enterprise. There's a lot of fear, uncertainty, and doubt about how to get started. We would just say that by using PLC Next, you've got an inexpensive, open, future-proof way to get there. You don't have to fear about going down the wrong path, getting started this way. The cost for the hardware is under $5,000 for everything you see up here on the hardware side, and that's the 2 complete systems. So if you were to just do one system, you're probably going to be under $2,500 on the hardware aspect. If you include all the software and everything surrounding it, including labor hours, which were about 20 hours to execute all this, we're probably talking about $20,000 investment. So that's what we have to talk about here today, and I thank Josh for doing the hard part.